Hi, this is a conversation with Juan Batiz-Benet. And Juan is a computer scientist, and he is also a student in various things. Juan, you have been working on Athena, which is a project in mapping knowledge. What is mapping knowledge, and why is it that you became interested in that?
Yeah, I think that knowledge is the most valuable resource on the planet. I think that when humans are able to understand things, they're able to then perform some action, right? So as simple as learning, if you take a human brain and you add the knowledge of being able to create fire, suddenly that human is now able to use fire. And I mean, this translates all the way through. It's from learning how to drive to learning how to do math, how to program a computer. Every single thing that sort of makes us unique as a species relates strongly to our ability to manipulate knowledge. And knowledge is not this abstract thing. It's a very concrete. It's sort of a subset of computer programs. If you sort of think of the human brain as a computer, a special kind of computer, and then you think of knowledge as the type of computer program that goes into this computer, then using this knowledge, which is sort of a model for some sort of set of actions for this computer, is some sort of instructions that this computer can sort of carry out, then this computer, the human, can then go out and do various things. And so while we can start with things like fire, discoveries like agriculture, where sort of the creation of new knowledge that enabled the species to get better and progress. And so throughout our history, our progress is very tied to our ability to manipulate knowledge. Sort of like the big technological advances that we see, things like language and writing, the printing press, and the internet. These are all information technologies that have allowed us to sort of manipulate and spread bits around faster, but more importantly than that, have enabled humans and human brains to work with knowledge in different ways. So it's not just about sending information and spreading it, it's also specifically about how humans interact with and use knowledge. So language was a way to exchange knowledge from one human to another. Writing was a way to store knowledge into the world. The printing press was a way to copy knowledge very cheaply and efficiently. And then now the internet today allows us to send knowledge across the globe really, really quickly. So the big question is, what will be sort of the next technology that will speed up humanity in this way? Like that will, and my big guess is that it will be this kind of knowledge technology, some sort of invention, some sort of thing that will enable us to learn knowledge faster and take action with it. So from that, after sort of looking at how I and other people manipulate knowledge, I realized that like one of the biggest bottlenecks today is in how we are able to extract knowledge from the world. And that we might be presented with textbooks or lectures or other people that have very valuable knowledge, but our intake of that knowledge is very slow at the moment and is very haphazard and sort of almost like not quite a random walk through knowledge, but because we have classes and universities and colleges and books that sort of provide a kind of like a tour through the world of knowledge, but it's not as efficient as it could be, right? So I want to have sort of like directions, have a very well-charted map of knowledge with directions explicitly for taking me from point A to point B in knowledge.
In this project, what is the most challenging challenge?
Well, there are many challenges. I think some of them some of the big ones are actually finding the structure to knowledge. So the sort of idea behind, talking more concretely, actually mapping knowledge means creating a graph of concepts, of human concepts, and sort of human proficiencies over a set of skills, and figuring out the relationships between these concepts and skills, and sort of kind of like an ontology of human knowledge. And there have been many attempts to do this in the past. In history, there have been many trials to sort of create the ontology of knowledge, and all of them have failed in some way or another. And part of it is the need for a lot of data. part of it is that it's hard to reach agreement and consensus on what exactly is or isn't a concept, on what on how these concepts relate, and that's sort of a part of why these past attempts have failed, because they sort of took one person or one group's point of view in how to structure knowledge. And instead, sort of the challenge here and how I've chosen to go about it is to create to just sort of let knowledge speak for itself. Try and figure out the structure of knowledge by seeing how humans currently learn. So first of all, you can sort of initialize a graph with a set of relationships by looking at current classes and current courses or textbooks, and sort of how curriculum through schools today teach certain subjects. So you can see, for example, that before you learn calculus, you should probably learn arithmetic for sure, and potentially algebra. And so you can sort of see a dependence between these things. Or even more specifically, something like before you understand multiplication, you should learn addition. Right? And so we sort of feel confident about these things, but we don't know for sure that that's the case. And while those are sort of clear examples, there are others that are much more unclear, or that you could take multiple paths to. So figuring out how to broach that sort of multiplicity of paths is a big challenge. And sort of the approach here is to sort of initialize with one perspective, and then over time organically adjust the graph to either add or remove or sort of rank paths as people can take different approaches to learning different topics and different concepts specifically.
You have been involved in StartX.
Yes.
Can you tell us something about
Yeah.
StartX Medicine, and what is its relevance?
Yeah, so Athena is a startup, and it's a project that is a company, and I went through StartX with Athena, and I've actually been part of the program for a while. StartX is a startup accelerator at Stanford University, and so it was started by Stanford students that got together and said, hey, it's kind of annoying to not have resources when you start a company, or not have mentors, or not have a sort of collective sort of pool of institutional knowledge that can help you broach some of the common challenges that all startups go through. And incubators have existed before, and accelerators, which is sort of like the new take on incubators. There are many of them. Other ones are like YC or Techstars and so on. And StartX's big thing was about enabling Stanford students who are trying to build companies with a Stanford network sort of set of mentors and support. Out of this program, which was it was very successful, like it's I think on its third year now, I think almost 100 companies have gone through, if not more, and just sort of like lots of great technologies have gone to market through this program. StartX Med is a specific vertical of StartX which focuses entirely on the med school at Stanford. So taking ideas for technologies or sort of research that is at the edge of being sort of translated into some product, both from students or staff or the faculty at the medicine school, and helping them build companies that take those to market. And so StartX Med has now helped many medicine device companies, and sort of every year sort of takes some more of these groups of people and helps them, gives them all the resources and mentorship and guidance they might need, and helps them along the beginnings of the road. Because many things kill startups, right? So it's not that it's a bad idea or a bad team and so on. Like, even if you've nailed all of those things, you might not find the right investors, or find the right cycle to introduce your product, or didn't have quite the right product fit, or the clinical trials didn't go exactly right for a variety of reasons. And so having a lot of people that have had experience with all these problems be at your reach and be able to talk to them at any point and have their help is invaluable to these companies, and sometimes it's often life-saving. So having StartX and StartX Med, specifically for the med school, enables these students or faculty that are building companies to leverage each other and the alums to build a sort of like get the power of the network to help them through broaching many of the challenges they'll encounter as they build their companies.
Juan, most people would refer to you as an extraordinary person. Do you consider yourself extraordinary?
I don't consider myself extraordinary. I think that I've gotten the chance to do extraordinary things, and I perhaps today have extraordinary abilities compared to the abilities I had when I was born. And it's also very dicey when you sort of think about what makes a person extraordinary or not. I think that I had a great set of ideas. I learned a great set of ideas that have propelled me and inspired me through many challenges, and have enabled me to see that I can learn anything I want to learn, that I can do anything I want to do, and that the world is there, and I can choose to manipulate it and change it in whatever way I think is valuable. And so I am propelled to do all of this because I have an innate sort of desire to learn more and to understand the universe and to figure out how things work and enable other people to do the same. So I would say that it's the ideas and the values that I have grown up with that have made me who I am today.
Who are your heroes? Who inspires you? Or what?
Well, many people. I have many heroes. I almost sort of have a sort of pantheon of sorts, or not pantheon, but like a humanist pantheon of sorts. Sort of at the top of the line are people like Richard Feynman or Carl Sagan or Elon Musk, and it's both scientists and entrepreneurs who have sort of gone after what they thought was most valuable and worked relentlessly to achieve it, and sort of always made this great contribution to the world in so doing. So one of the reasons I find Elon Musk an incredible figure is that he has sort of single-handedly, although of course with a large army of engineers and amazing people that work with him, he has sort of returned to us the dream of space and going back and becoming a multiplanetary species, which I think is one of the most important things that we have to do if we want to survive in the long run. But he's sort of taken it as a personal task, and he's working nonstop to make it happen. And not only did he do this, but he's actually succeeding at it, which is the hard part. Like, how do you, as an individual, build a company that is now competing with entire countries in order to get to space is amazing, and sort of that is extremely inspiring and can show you the power of an individual to sort of take matters into their own hands and get humanity to go where it ought to be.
Finally, Juan, do you think that there should be a different type of education for extraordinary people or for people who are not extraordinary?
I think this goes back to the question of like what makes an extraordinary person or not. I think people tend to think about it in terms of genes and memes, in terms of like, is a person born extraordinary or not? And once born, is a development of a person capable of getting them to be extraordinary or not? And I think there are, sort of on the genetics question, there's a lot of factors showing yes or no about certain things, or whether people are better or worse at particular things. But nevertheless, I think it's much more important to look at the memes that form a person's, that form part of a person's education. And I don't mean education in terms of like conceptual things that they might learn, but rather value systems that they adopt. Or, I think like the most important part of education is not sort of constructing a set of facts that people need to learn, but rather teaching people why learning is extremely valuable, or how to learn specifically. So understanding what are the set of ideas that a human mind needs to understand to think that learning is valuable is one of the things that we should be focused on when we think about education. And moreover, I think it has to be sort of like an individual approach. I'm not a fan of sort of this sort of kind of like treadmill model of like you have many different classes and you put people in one and then like out pops an engineer. I think it's very different for every person, and particularly when you go across the globe, you find all sorts of people with all sorts of background, all sorts of different proficiencies and abilities and interests, and everyone sort of requires a different approach or a sort of personalized, entirely personalized take on learning and their education. So rather than thinking of is there an education for extraordinary people or not, I think it's much more continuous in that there's so many different people with so many different interests and so many different features that you have to build a system that can account for those and provide an organic way of adjusting and personalizing their learning on the way. And I think this is best achieved through mentors and peers that can help sort of guide them along the way. I see teachers more as personal mentors that have taught me how to learn certain things or how to approach and discover ideas than as having taught me specific things.
Juan, thank you very much for sharing these experiences with us.
Absolutely.
And thank you too.
Thank you.